All right, I like to solve a problem like this by factoring. And some teachers call this the trinomial method, some call it the T-chart method, some call it the AC method. But this is in quadratic form, so it's in the form of ax to the second plus bx plus c equals 0. So in this case, a is 5, b is negative 34, and c is negative 7. So the reason I call it the AC method is because you make a little t-chart here and you take a times c, that will give you b. So for this problem, it'll look like this. It'll look like 5 times negative 7 is negative 35 and negative 34. So I need two numbers that multiply together to give me negative 35 and add to be negative 34. So I know that negative 35 times 1 is negative 35, and negative 35 plus 1 is negative 34. So once I find those two numbers, I'm going to rewrite this problem. So I'm going to rewrite it as 5x to the 2/3 power minus 35x to the 1/3 power plus 1x to the 1/3 power minus 7 equals 0. So whatever variable is on the middle term is going to be the variable on these two, because these two combine. Negative 35x to the 1/3 power plus 1x to the 1/3 power gives you negative 34x to the 1/3 power. So if you changed your trinomial to a 4-term polynomial. So the next thing I'm going to do is I'm going to group the first two terms together. I'm going to group these two together, and I'm going to group the last two together. So I want to take out what they have in common. So these two have a 5x to the 1/3 power in common. So when I do that, I'm going to take 5x to the 2/3 power and divide it by 5x to the 1/3 power. So 5 divided by 5 is 1. X to the 2/3 power divided by x to the 1/3 power. When you have the same base, you subtract the exponent. So 2/3 minus 1/3 is x to the 1/3 power. Negative 35 divided by 5 is negative 7. And then x to the 1/3 power divided by x to the 1/3 power cancel each other out, and you have just negative 7. So over here on this second set of parentheses, these really don't have anything in common. And the other thing you already notice is this parenthesis here matches this parenthesis here, which is what you want. But you have to take something out. So I'm going to take out a positive 1. And if I take out a positive 1, that will not change anything. So I still have x to the 1/3 power minus 7 in parentheses equals 0. So your goal is to get these two parentheses to match. Once they match, then your two parentheses come from the parenthesis that matches, so x to the 1/3 power minus 7. And then the other parenthesis comes from what you factored out, 5x to the 1/3 power plus 1 equals 0. So now what you can do is you can actually set both of these parentheses equal to 0 and solve. So I'm going to set x to the 1/3 power minus 7 equal to 0, and I'm going to set 5x to the 1/3 power plus 1 equal to 0. So this one I'm going to add 7, so x to the 1/3 power equals 7, and then to get rid of the 1/3 power is I'm going to raise it to the 3rd power, or I'm going to cube it. So I'm going to take this to the 3rd power, I'm going to take this to the 3rd power, and this is 1/3 times 3, using your power rule, becomes x to the 1st, and then 7 times 7 is 49, and then 49 times 7 is what, 343, I believe? I might check my math there. And then over here on this one, I'm going to subtract 1. So I have 5x to the 1/3 power equals negative 1. I am going to divide by 5. So I'm going to divide by 5. So I have x to the 1/3 power is equal to negative 1/5. And then the same thing, I'm going to raise this one to the third power. So this will become x to the first again. And then negative 1/5 times negative 1/5 times negative 1/5 is negative 1/125th. And those should be my two answers, but you make sure you check the answers.